So let's talk about problem 2 that we're going to put onto our posters. Problem 2 says for a second batch of sauce 1 and sauce 2, Andrew plans to use 3,180 green peppers and 5,560 hot chili peppers. So for your problem right now, you want to be changing the amount of supplies that you're buying. So you're going to change how much of each supply you're going to buy, and that's going to change your setup here. Write a system of equations that shows how Andrew can use the peppers to make X pints of sauce 1 and Y pints of sauce 2. Identify and describe a method you could use to solve this system. Explain your choice and give the solution. I'm going to have to go back to page 1 to remember how many green peppers and how many red peppers are used for each type of sauce. So, sauce X uses 6 and 4. So I'm going to write that 6 and 4 for the X's. And then I'm going to check for the Y's. 3 and 10. So 3 green peppers, 10 red peppers for the sauce 2 batches. Basically, that is our setup. All we have to do now is add the green peppers and the red peppers, and that's going to equal the new amount of supplies. So 3,180 and 5,560. And that's for the hot chili peppers and for the green peppers. The second part of this is asking us to solve this system. And we can choose graphing, we can choose elimination, or we can choose substitution. I'm going to choose to multiply each equation by a constant and solve this using elimination. So let me grab a new color just to make it clear what we're doing. I want a number that can help me eliminate the 6 and the 4 and the X's. Now, however you set yours up, it could be different. But I'm going to multiply each of these equations by a number that will give me the same number for the X coefficient. And if I list my 6's and my 4's, like I have 6, 12, 18, and then I have 4, 8, 12. Well, I can stop there because the 12 is in common. So I'm going to multiply the top equation times 2, because 2 times 6 is 12, and I'm going to multiply the bottom by a -3, and the reason I'm doing negative is so that I get a negative coefficient, a -12, to cancel with the +12. We want opposites. Okay. So you're going to do this in your problem. And I'll pause it so that way you have time to first write down your equations, and then we'll come around to help you figure out how to solve this using elimination. And on your poster, instead of like writing this, explain your choice and give the solution, you can just say part A, elimination. All right, when we multiply, we get 12x plus 6y equals 6,360. That's for the first equation. The second equation, I'm multiplying times -3, so I get -12x. -3 times 10y is -30y. And -3 times 5,560, I'm going to need a calculator for that. Okay, so when I multiply -3 times 5,560, I get -16,680. Now I want to combine these equations. So I'm going to eliminate. And the 12 and the -12x cancel. 6 and -30. Since one is positive and one is negative, I'm going to subtract. And I get -24y. And then same thing with the 6,000 and the -16,000. I'm going to subtract. And I get -10,320. Then we're going to divide that by 24 on both sides. So that gives us y equals -430. Actually, I'm sorry, it gives us a positive because we divided by a negative, right? That didn't make sense to me. I was like, that doesn't make sense. We shouldn't have a negative. So what does that mean? That means that we can make 430 pints of sauce 2. But is that our final answer? No, we have to plug that in to the y so that we can solve for x. So which original equation do you want to plug it into? I kind of like the 10, right? Like 10 times things are easy. So I'm going to choose the second equation to plug into y. So 4x plus 10 parentheses 430 is equal to 5,560. When I multiply by 10, that just adds a 0, so it's going to be 4,300. Bring everything down. Minus 4,300. Bring down the 4x, the 4,300 and the -4,300 cancel. I subtract, and I get 1,260. Because you're making up your numbers right now, you may get decimals, and that's okay. If I divide by 4, I get 3, and 4 goes into 16, 60, 15 times. So I could make 315 pints of sauce 1. Oh, I highlighted these the wrong color from before. So if I wanted to be consistent, sauce 1 would need to be blue highlighted, and sauce 2 would need to be yellow highlighted. Not a big deal, but if you're color coding, you want to be consistent. So we'll pause now and let you take time to do this math for your problem. And if you have questions, let us know. We're coming around to help. And also, you might want to be doing this on a scratch paper before actually putting it on your poster. Part B of the second question, it starts to get exciting. Andrew plans to sell his second batch of sauce. He will make a maximum profit if he uses all the preppers and sells all of the sauce he makes, right? And so we just discovered that if he made 430 of sauce 2 and 350 pints of sauce 1, that is going to use up all of the peppers. So what is his maximum profit if he makes $1.20 per pint of sauce 1 and $1 profit per pint of sauce 2? Explain. So I'm just going to color code it how I did before. Sauce me see, I'm sorry, sauce 2 is $1, and sauce 1 is $1.20. So he makes more profit. And you can just decide on your own what profit you would want to make for each of your items that you are selling. So for depending on each version, one version may cost more than the other version. Okay, so decide right now how much you're going to make as a profit. Not how much you're going to sell it for, but what will your profit be? So let's say it cost you $5 to make something, then you want to sell it maybe for $10, and then your profit would be $5, right? Because you would subtract how much you're selling it for minus the amount that you spent on supplies. All right, so now we're going to take the Y, the sauce 2, or maybe we should take sauce 1. Sauce 1. If you have 315 pints that you're selling for $1.20, you just want to multiply those. And then for sauce 2, you're selling 430 pints at $1 profit. So when you multiply that, you get $430. And let me get my calculator for this one. 315 times $1.20 is $378. Now if we add those together, we get a total profit of $808. All right, and that is problem 2. And then we'll do problem 3 after you have a chance to find your profit on your problem that you created. On problem 3, we are going to be working with inequalities. For a third batch, Andrew buys 240 green peppers. I'm sorry, 2,400 green peppers and 3,200 hot chili peppers. That's the maximum he can use. And that's why he bought these based on customer demand. He'll decide how many of those peppers he will use to make sauce 1 and sauce 2. So again, sauce 1 we'll use blue, and sauce 2 I'm going to use yellow. We want to write and graph a system of inequalities to show the different amounts of each type of sauce that Andrew can make. All right, so back on the front page it tells us how many green peppers he uses for X and how many green peppers he uses for Y, because we're using X and Y for sauce 1 and sauce 2. And for the red peppers, he used 4 for sauce 1 and 10 for sauce 2 for the hot chili. And we want to use less than or equal to on both of these because he can't go above. And this is just coming from our problem. This is how many green peppers he bought and how many red peppers he bought. Now, I like using intercepts when I'm graphing. So to graph my intercepts, I just have to divide. So for the green equation, I'm going to divide 2,400 divided by 6 to find the x-intercept. And then I divide 2,400 by 3 to find the y-intercept. And then I'm going to graph it. So for my x, I had 400, that's pints of sauce 1. And for my y, I had 800. And I will use a solid line because it was less than or equal to. And then I will lightly shade below. Okay, now I need to find the intercepts for the red chili peppers. So I do the same process. 3,200 divided by 4 will give me the x-intercept. And I think that's 800 again, right? Because 4 times 8 is 32. That's for my x-intercept. And for my y-intercept, I'm going to divide by 10. So that's 320 for my y-intercept. Choosing your scale is going to be important when you're drawing your graph because you want to count by things that are going to work out for you. So I'm going to pick 800, and 320 is going to be a little bit more than 300. And I'm going to shade below again. It's like New Mexico, we have Christmas, right? So shading below where we have Christmas is going to be the region where he can use both peppers and make his sauces. So that would be the solution. And we could say he could make 300 pints of sauce 1, 200 pints of sauce 2, because that's the point where they cross. That would give him the maximum use of his peppers, but he could also make 100 and 100. Or if they're liking sauce 2 better, he could pick this point right here, which would be 100, 300. Or if they're liking sauce 1 more, he can pick a point that's over here. That would be more pints of sauce 1 versus pints of sauce 2. Okay, and that concludes our project. So go ahead and do these steps for problem 3 on your poster with the items that you will be selling in your poster.